So this problem is asking, what is the gradient or what is the unit normal vector to the three-dimensional function? The unit normal vector is a vector that at some point p, which we're being given, it is orthogonal or perpendicular to that point on the surface. So essentially it creates a right angle with everything on that surface. This unit, this normal vector is also known as the gradient of the entire function. And we can give the normal vector as n hat. Now, a unit vector is just a vector with a magnitude of 1. So what that means is that we'll get some vector n that's normal to the surface, but we just divide that by its length to scale this down to 1. So a unit vector is just any length vector that's scaled down to a length of 1. All right, so if we have this function here, we can go ahead and make it a little prettier, easier to deal with by using a logarithm rule, which is negative 4x, ln of negative 4x minus ln of negative 5y minus z. All right. Now what this is going to allow us to do is this is going to allow us to take the gradient of f, where this will be in vector notation. This is going to be df partial derivative with respect to x, partial derivative of the function with respect to y, and then partial derivative with respect to z. At, and we'll use this symbol, you've probably seen this before, at the point P that they're providing. In this case, it is negative 4, negative 5, 9. All right, so this is going to be our normal vector, and to make it a unit normal vector, all we do is divide by let's just say we can call this the normal vector n. We just divide by the magnitude of n. Now, to get the magnitude of it, you're just taking square root. So the magnitude of n, you're just taking the square root of df over dx squared plus, and you're squaring this whole thing, df over dy squared plus df over dz squared, all under the square root. And that will bring your whole vector to a length of 1 just by dividing it. This is just simply scaling the perpendicular vector. So to do this, to take the derivative of f, what we'll do is the derivative, a partial derivative with respect to x ignores the y and x, the y and z terms, and it's only picking out that ln term. And in fact, that derivative is just 1 over x. And then the next derivative, second derivative, the partial derivative with respect to y, is just going to be negative 1 over y. And then we're going to have, let's see here, negative 1 over z. All right. And then we can go ahead and plug our values in. So this is 1 over negative 4. And then 1 over 5. And then negative 1 over 9. And then to normalize that, you just divide by the magnitude of these. So square these each and then divide by. So essentially, this n magnitude vector is just going to be 1/4 squared plus 1/5 squared. And you don't need the negative because it's all being squared over 1/5 squared plus 1/9 squared. All right. And then you should be able to be good to go from there.